Welcome to solverfy.
Okay, we've been given the following structural formula. Central carbon, up and to the right there's a carbon with 2 hydrogens, and down and to the right there's an oxygen with 1 hydrogen bonded, and from that central carbon down and to the right there's a carbon with 3 hydrogens attached. There is a hydrogen attached to our central carbon down to the left, and up and to the left is a carbon with 3 hydrogens attached. All right, and what we need to do is determine what the best condensed structure formula for this molecule would be, right? And so we're given a few options. So one of the things that we will likely notice is that we have branching, right? From this carbon, there are more than 3 paths we could take. That is, we could start at this carbon, go to this carbon, and then go up here and consider this the main chain and this branching off. Or we could consider this to be the main chain and this all to be branching off. So there are options to consider in that manner. And then the final thing is, if we're our final option would be to consider this carbon to be the starting point, but each of these methyl groups to be simply branching methyl groups sticking off of it, where this would be our chain, and then we would have, for example, CH3 2 branching off of a central carbon. So we'll just keep those in mind as we go through the options that we've been given, and we'll see if those make sense with the structure we have. So the first structure we have says CH3, CH, CH3, CH2, OH. Now there's a problem here in that once we specify CH3, if we aren't at the beginning or doing it in parentheses, that's just an invalid structural formula, right? So if we were to instead put this in parentheses, this would be the equivalent of saying we're starting at this CH3, then we move to this CH, then off to the side we have this CH3, we would put it in parentheses, then we're continuing on to this CH2 and then OH. But because it doesn't have parentheses, that doesn't work. Okay. The next one we have is CH3, CH2, CH2, OH. Okay. The problem with this one is that we don't have CH3, CH2, CH2, OH, right? That would be carbon, 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 OH, right? All in a line. At no point do we have a line of 3 carbons, right? So this also cannot be, neither of the first 2 are possible. Okay. Now we have, in parentheses, CH3, 2 of them. Then we have CH, CH2, OH. And this is pretty much this is our best one. And so I will redraw our initial structure and then explain why this is a good representation of that. So they say C, right? And then we have CH2 up here, then an OH down to the right. Down below we had a CH3. Then we had an H down here. Oops, H. And then up and to the left we had a C with 3 hydrogens. Okay, so what they've done is taken this CH3 and this CH3 and represented it with, to indicate branching, CH3, 2 of them in parentheses, which implies that they are sticking off of this carbon, which I'm drawing in red here, right? From there, we're saying that there's 1 hydrogen attached to that carbon, which is true. We can see it in our drawing, right? And then to finalize it, they say there's a CH2, which should also be considered attached to the red carbon, right? Being that it comes directly after it in the formula, and we know that there's a CH2 right here. And then the formula implies that it's attached to an OH at the end. OH. Here is our OH, right? So the third option is the best representation of the following compound. The remaining two are bad for reasons similar to the first two are bad, but we can also just stop here because clearly this is correct.